Good morning, all of you. Today, we'll discuss our another topic of machining principle and machine tools. Today, we'll discuss tool material, basically cutting tool material. Okay. In earlier lectures or earlier days, we have studied the tool geometry. Machining principle include the tool geometry or shape or size of the tool. Then we studied the type of chips or mechanism of chip formation and what are the basic types of chips formed in during machining. Then we have studied the mechanics of machining. What are the basic type of forces acting on tool chip interface during machining? Uh, how we calculate these forces with the help of merchant circle diagram. Okay, then we have studied that heat generation during machining. This is a very small part, heat generation during machining. Okay, then we have studied the tool life, tool failure. Okay, now we'll go for cutting tool material. Okay, first of all, what are the basic fundamental properties which have the cutting tool materials? To design a cutting tool materials, we have to select the proper. To design a cutting tool, we have to select the proper material because material includes the strength, okay, hardness, all the mechanical properties, toughness, creep, plasticity, elasticity, all the mechanical properties we have studied earlier in our strength of material subjects. Okay, now the different types of properties. The basic fundamental requirement is the what are the main properties which have the cutting tool material. First of all, first one is high mechanical strength, because high mechanical strength means tensile, compressive and shearing. Okay, I am writing in short form. T for tensile, C for compressive, S for shearing. Hmm. High mechanical strength which if the cutting tool material have the high mechanical strength, then there is a property which acted to resist the breakage of tool or tool tip, because the tool tip or the cutting tool edges are very sharp. If the strength is not very high, so that at the very first time when chip and tool and job are in contact, then there is a chances of mechanical breakage. I have already told in our tool failure topic. Okay, second one is high hardness. Second one is high hardness. Okay, Why hardness is required? Because if the job material and the tool material hardness is no is very much close, then there is a chances of rubbing action. So cutting tool material have the high hardness property, almost 30% to 50% more harder than the job material. Okay, more harder than the job material. Okay, why? In order to reduce the abrasion wire. Okay, now next third point is high hot hardness. High hot hardness. Uh, the part is hot. That means at elevated temperature, the hardness of the tool should retain. What is meant by this? High hot hardness. Where the high hot hardness means high hot hardness. That means the hardness of the cutting tool material at high temperature, because there is a there is a situation when the tool or chip is called tool and job is continuously are in contact. There is a frictional energy released by the job or tool, so that the high amount of energy is released, so that the temperature at the contacting zone between tool chip interface is very high. So at that situation, if the strength of the hardness of the tool if lower, then there is a chances of the tool become goes to plastic region. So the edges of the tool, for principal cutting edge or auxiliary cutting edges are uh, may be damaged, so that the geometry of the cutting tool is is damaged, so that high hardness is the main part. Okay, next fourth point. Fourth point is toughness. Toughness. Now already know what is toughness. It is a ability of material to absorb the energy before fracture. That means cutting tool material always have the high toughness. Otherwise, it is not absorbed. It is not absorbed the high amount of energy which is released by the job tool interface region. Okay, next is chemical stability. Chemical stability. Chemical stability is high of the cutting tool material. Otherwise, there is a chances of diffusion. We already know diffusion where if The chemical stability is not high, so the diffusion wear is occurring at the two chip contacting regions, so that there is a atom transfer between tool and the chip material or job material. Okay, six. High stiffness. We already know what is stiffness. It is the ability of material to resist the deformation. Okay, high thermal conductivity. If the thermal conductivity is so high, then the heat transfer rate is also high, so that the maximum heat of the tool chip interface region is released, okay, from the contact region, so that there is no chances of deformation of the tool. Okay, so high thermal conductivity is also the requirement. Okay, next. There are so many properties. We have discussed only our main properties. Okay. First of all, the number is 8 is fatigue, strength. Fatigue strength is also very high. If fatigue strength, we know the fatigue. Fatigue means it is a dynamic loading condition. Dynamic loading condition. Okay. In dynamic loading condition, dynamic means loading, the load variation. Okay, during load variation of load, there is a chances of the mechanical breakage, so that during dynamic loading, the strength of the strength of the cutting tool material should not go lower, so fatigue strength is also high. Okay, next, type.